Hello everyone, and welcome back to the Fluctus Channel. Lasers have been a part of warfare for decades since the first laser machine was built. Only recently has the direct offensive use of lasers proven to be more viable as smaller and more powerful energy sources have been developed. One such system is the Boeing YAL-1. Theodore Maiman invented the first laser on the 16th of May 1960 at the Hughes Research Laboratory in Malibu, California. Maiman utilized a high-powered flash lamp to illuminate a ruby with silver-coated surfaces, causing the laser to activate. It took 36 years before this technology was incorporated into Boeing's YAL-1A airborne laser program, which converted a Boeing 747-400F into a high-powered missile defense platform. The initiative, which began in 1996, focused on developing enhanced missile interception capabilities using chemical oxygen iodine laser technology. A chemical oxygen iodine laser, COIL, is a near-infrared chemical laser that is invisible to the naked eye. Our atmosphere, however, causes distortion. YAL-1A's deformable window and laser beam control system compensated for atmospheric distortion using adaptive optics. 6 enormous optical windows positioned in the aircraft's nose turret had deformable mirrors that could be changed hundreds of times per second to maintain beam coherence and accuracy. The technology adjusted for wavefront aberrations induced by atmospheric turbulence, ensuring that the high-energy laser remained focused on the target missiles during the boost phase. This advanced beam control technology enabled the laser to provide maximum energy to the target despite aircraft vibration and atmospheric conditions at operational altitudes. Lasers are proving to be useful in countering UAVs, unmanned aerial vehicles. The U.S. Air Force has been conducting directed energy weapon tests at White Sands Missile Range, pitting high-powered microwave and laser systems against unmanned aerial vehicles. The laser system generates kinetic effects by burning holes in target drones, causing them to crash.
Most of the time we actually hit that and it actually burns a hole, a kinetic effect where it actually drops it out of the sky because of that burned hole. With high-powered microwave, it may be a little different. It may just interrupt the actual performance and the weapon system will have to go back to where it came from.
These devices, which are currently at a high stage of technology readiness, are designed to safeguard bases from drone monitoring. Another system was also tested by the U.S. military. The high-energy laser mobile demonstration is a truck-mounted 50-kilowatt laser device that can melt through steel and destroy small, unmanned aircraft.
I'm an artilleryman by trade for 37 years. I'm very excited about the future of laser technology. Our job at West Point is to educate, train, and inspire the future cadets for our great Army. It's very important they become practitioners for future battlefields.
During West Point trials, the device demonstrated precision targeting capabilities. blazing through a variety of materials while yet permitting manual operator control. Unlike traditional weapons, this directed energy device has instantaneous effects on the target and causes minimum collateral harm. Another laser was mounted on an AH-64 Apache. Raytheon and military partners reached a critical milestone in June 2017 when they successfully integrated a high-energy laser weapon onto an AH-64 helicopter. Testing at White Sands Missile Range demonstrated the system's ability to track and engage targets while dealing with aircraft vibration and rotor wash. This was the first time a fully integrated laser system worked from a helicopter, demonstrating that directed energy weapons could be used from rotary wing vehicles. Laser power is also becoming more powerful in other areas. The Naval Surface Warfare Center showcased groundbreaking power beaming technology in the David Taylor Model Basin in May 2023. Two 13-foot towers, each with a 2-kilowatt laser transmitter and a customized photovoltaic receiver, successfully delivered 400 watts of invisible laser power over 325 meters.
The kind of technology that can change how we think about moving energy. We are taking a laser and shining it to a photovoltaic receiver, and photovoltaic is very similar to solar cells, but they're tuned for the laser wavelength, and essentially transmit power without a physical infrastructure.
This free-space power beaming system demonstrated prospective uses for wireless energy transfer, representing a significant development in directed energy technology for naval applications. A promising area is using laser weapons from ships. In 2020, the USS Portland successfully demonstrated the Laser Weapon System Demonstrator, LWSD, by disabling a UAV target. This 150-kilowatt solid-state laser system represented a significant leap in naval-directed energy weapons. This test expanded on previous deployments of lower power systems, illustrating the Navy's progress toward creating ship-based laser weapons for fleet defense. Technology has also given us non-lethal methods to deal with crowds that pose a threat to public safety. Non-lethal weapons give military and security forces escalation options, ranging from verbal warnings to lethal action. This category includes advanced directed energy technology such as the Active Denial System, ADS. Unlike typical non-lethal weapons, which need physical contact, ADS operates at enormous standoff distances that exceed small arms range. The technology sends out a focused beam of millimeter wave energy that only penetrates the outer one over 1/64 inch of skin, forcing targets to instinctively move away without causing permanent injury.
We're radio frequency. We go through the air as an invisible beam, and we've determined with 15 years of research that we're only heating that outer 1/64 of an inch, causing a very robust repel response.
Crowd control, base defense, checkpoint security, area denial, and sensitive facility protection are all applications that the system excels at. This technology enables security forces to maintain safe distances while managing situations that do not require lethal force. Solid-state active denial technology, SSADT, is a cutting-edge, non-lethal directed energy system that uses 95 GHz millimeter waves. The device generates an invisible, quiet beam that travels at light speed and penetrates skin to a depth of 1/64 inch, causing an uncomfortable heating sensation and forcing targets to move away. This technique represents a substantial leap in non-lethal crowd management and force protection. The system's adaptable design includes 360-degree coverage and electrical steering control for precision target engagement. Vehicle mounting choices improve mobility, while glass penetration capabilities increase efficacy against vehicle-based threats.
Wow. Freaking hot. That is awesome. That is sick. That is hands down awesome. That's like, nope, you're not coming down this road.
Multiple redundant control systems enable precise beam positioning and power management. SSADT's operational applications range from urban combat mobility to entry point security, making it especially useful in crowd control and convoy protection. The system excels in perimeter defensive tasks, giving commanders flexible response options. The idea behind palletized missiles or bombs centers on enhancing the flexibility, rapid deployability, and overall capacity of air forces to deliver long-range precision strikes. By using palletized systems, missiles or bombs can be preloaded onto pallets and launched from cargo aircraft using standard airdrop procedures. The pallets themselves can be constructed in a matter of minutes. Before long, an airstrip that previously had no bombing capabilities can utilize virtually any large aircraft to launch a full air-to-ground strike. When it comes time for launch, the Rapid Dragon system operates just like a cargo drop. The bombs are armed before being ejected from the aircraft in their palletized containers. They then deploy parachutes to stabilize and orient the munition for launch. Once stabilized, the missile is launched toward its target, while the aircraft remains at a safe distance. By using cargo aircraft that are not typically associated with strike missions, forces can potentially catch adversaries off guard. Additionally, the range of the missiles allows for strikes deep behind enemy lines without putting pilots and high-value aircraft at risk. As we've seen, directed energy is no longer a concept of the future. It is rapidly becoming a core component of modern warfare. From airborne laser platforms like the YAL-1 to ship-based systems, mobile ground units, and even non-lethal crowd control technologies, lasers are reshaping how militaries detect, track, and engage threats. Targeting systems and adaptive optics continue to advance. The battlefield is evolving toward faster, more precise, and more flexible forms of combat. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.